So hello guys. So till now we have seen you can write the data to a Parquet file. You can write your data to the Delta file. You can write it to the Delta table, CSV, JSON, anything. But what Databricks recommends us to write it into the Delta format. So what exactly is the Delta? What is their lakehouse architecture? They are calling it as a lakehouse. So what exactly is this lakehouse? So let me explain you that. So for that, let me go to Databricks account. So they got a very cool feature as a lakehouse. So what they call it lakehouse as, they are using data warehouse and data lake both. They have merged both. Your Databricks has introduced the lakehouse, which is a combination of both. I would like to show you this GIF. You can see on their website. Your data warehouse and data lake both clubbed together forms you a lakehouse. So many folks are still getting confused what exactly is the lakehouse, where exactly is the lakehouse. So your data lake is only a lakehouse. Your data lake, if you are converting that to a delta, it becomes a lakehouse. So what I mean to say that when you are writing any files back to your ADLS, if that file format is a delta, or if that table's metadata is storing in a delta format, your ADLS will act as a lakehouse. So lakehouse is nothing but it is a combination of both data warehouse and data lake. So your lakehouse is nothing but your ADLS only. But if you write the files in delta format, it becomes a lakehouse. So this Databricks people have done a very good job. So they have pulled out some negative points from data warehousing. They have pulled out some negative points in data lake. Okay, what I mean to say, they have pulled out some very good points from data warehousing, very good points from data lake, and they have clubbed both and introduced a lakehouse. So let me show you this slide. You can easily understand what I'm trying to say. So if you talk about data warehouse, we know that it handles only a structured data. If you have a semi-structured, unstructured data, it will not handle at all. And your all your data warehouses are your schema on write. So when you are writing it, you need a schema for that. But when it comes to the data lake, it's schema on read. And data lake, we all know it can handle all types of data, structured, semi-structured, unstructured, all that. When it comes to asset transaction, data warehouse has a very good support for data warehouse. But data lake doesn't have, I cannot say doesn't have, it has a very minimal support for asset transaction. In case of your system corrupts, data warehouse doesn't leave your system as a corrupt, but your data lake can leave your system in a corrupted state. So if you look at some negative points, these are only few points what we have pulled out, but there can be many other points. So there are some negative points in the data warehouse, some negative points in the data lake. What these people, Databricks people, have done, they have introduced a lake house that is bringing all the positive points from data lake, all the positive points data warehouse, and they have built a lake house. So many are getting still confused, where is the lake house? Lake house is in your data lake only, but if you get a file of delta, that becomes a lake house. So what it can do, it can handle all structured, semi-structured, unstructured, streaming data also, and it is obviously schema on read. It has a very good support for ACID transaction because it has the property of data warehouse, and it doesn't corrupt your system because it has the property of data warehouse. So who has introduced this lakehouse? Obviously Databricks people have introduced this lakehouse. Now everyone, those who are working on big data, data analytics, data science, data engineering, everyone is talking about this delta. Why? We are going to see in detail like why and why it is getting so much popular. So before that, let me show you what they have done. So they have built this delta, and they have given it to the foundation again. So now Delta Lake is a foundation of a Linux that is based out of Linux Foundation. You can see Linux Foundation, and this is developed by the Databricks people only. So they are so smart. They have started building Spark first. To run Spark, they started building Databricks, and they have built their own Lakehouse, that is you can call as a storage layer. And they wanted a format. They built a Delta Lake on top of that. They also built some ML flow and few of the things. So now Delta Lake is a found it is owned by the foundation of Linux, but all other big companies, those who offer big data analytics, also use the format of Delta Lake. So I can talk like a biggest competitor for Databricks is Snowflake. Snowflake is also talking about this Delta Lake because they have so many features where you can do with Delta Lake. We are going to talk about that. So, what it can do. So, your Delta Lake sits exactly on top of your existing data lake. Very simple. It sits on top of your data lake. Now, we are using an Azure data lake. On top of that data lake sits your Delta Lake. So when you are saying about Delta Lake, it accepts or it takes up both streaming and batch. And when you are talking about Databricks and when you're talking about this Lakehouse or Delta Lake, it has a medallion architecture. Now, what exactly is the medallion architecture? Is like it creates the layers when you are creating or when you are working on the tables. So it says that when you are ingesting it, you create an ingestion table, you call it as a raw table, you call it as a bronze table, you you call it as a bronze table. Then you start cleaning it, you start filtering out it, then you call it as a refined table, you call it as a silver table, and then at the final will be your gold table or it is your aggregated table. So this gold table is used for your business analytics, your machine learning, and it can be for any other use. So you can create various layers and all can be your delta table. Now again the question might be coming to you like what is delta and why we are all talking about delta, even though we have so many other formats, we have Parquet files, we have other file formats, big data file formats, but why we are talking about delta, let us see it now. So it is open source now, it is very simple, production ready, platform agnostic. Then coming to the features, very important, Delta Lake accepts your asset transactions. It handles the petabytes of data, huge amount of data. Very important feature. It the key feature is it allows us to time travel. You can go back and check, "Hey, what are your records? Can you please send me your records?" You can go back and check all your records. It is open source. It unifies both. You can club both batch and streaming together. And the good feature of this delta table or delta lake is you can create tables by using Spark, you can use PySpark, you can use SQL and all those things. Schema evolution, schema enforcement. If you have any bad record, if you are getting a corrupt records coming in, you can do a lot of things with that. There is an audit history. And when you are talking about data lake, can you do the DML operations on top of that data lake? No. Till now, we did not do any operations on the data lake. But when you have a lake house, when you have a data log, you can perform a literally DML operations on that. You can do merge, you can do updates, you can do inserts, you can do all that when you are calling as a delta lake. So these are the features. So we'll break down one by one each of the key feature and go in detail. So let me show you a simple pipeline if you're working without delta and with delta and without delta. So if you are talking without delta, it means that you need to use a data lake separately. You need to use a data warehouse separately. So what does it mean? You are getting some logs from your database. You are getting some data from your IoT sensor data. You are creating an ETL job one, creating a job two. You once you are done a ETL, you convert that to a Parquet file. That Parquet file, Parquet table will be stored in your cloud object. it might be your data lake, it might be your anything. In our case, let us assume that it is ADLS. So you will create number of tables, part files, but this cannot be directly connected to the BI because this is just a data lake. You need to move your data from this data lake to a data warehouse. You need to convert that to a your regular table. Once you get the data into data warehouse, then you can use it for further downstream for BI users or maybe for the ML users. But if you are working on this delta format, very simple. Once you convert to your ETL, don't write it to a Parquet file. You can just write it to the delta format because this delta works as both. It works like a data lake also, it works like a data warehouse also. So you don't need to move your data again to a data warehouse. You can cover it there only. So you can see the data movement has been drastically reduced, and from here directly you can connect it to the BI, ML, data scientist, and so on. So in this architecture, you can clearly understand how Delta Lake is helping us to use a very less components in their ETL. You can see the organizations that have contributed to Delta Lake. You can see top tech, all tech giant companies. Databricks is there, Amazon is there, Apple is there, Adobe is there, and there are so many other thousands of companies. Those who are having or have contributed to the Delta Lake. So let us move on to Databricks now to do the hands-on on all about the Delta Lake. So what I'm trying to do now, guys, so I have an account here like ADLS account. I have one container here. I have a container name called as a raw here. This is my ADLS account. I am trying to mount this ADLS to my Azure date, not Azure, a community edition of my Databricks. So let us do that. So let me start creating a notebook here saying delta. So we are going to see how to create a delta table. Actually, there are multiple ways you can create a delta table. So I have got a new notebook creating a delta. But before that, I would like to mount my ADLS to my Azure to my community edition. So for that, I have a script here. Maybe I'll just copy that. I have a script here. I'll just copy it. So this is one more a quick revision how you can mount your ADLS to the community edition. I'm doing it by access key. I'm doing it by access key because if you are working on service principal, you may not able to do that in a community edition because service principal for service principal you need an Azure Active Directory and also you need a uh, Databricks premium account to use a backed secret scope. We have already done it. If you want, you can just pause the recordings like how we can use a service principal to mount it. But now I'm just using an access key in a simple way. Now you need a container name here. So the container name is let me write a container name that is raw. So I'll just take a container name here and write raw. Okay, and storage account name, your storage account name is SANLY, that is storage account, and my name NLY, storage account NLY. And here also you need mount point, so I'm just mounting it mount, and I'll be using a storage account name, a standard practice NLY, and just write raw container. And here I need a storage account name that is SANLY. Okay, and after this you don't need all this. Let me cancel out this, and you need a secret key of your Azure account. So this is just for a practice, so I am just compromising my keys. When you are working on a real time, you may not use in this way. So I'm just copying this, yeah, and I'll be just pasting it in the keys here. Okay, so here I need to put a semicolon only. Yeah, now let me execute this. So if everything looks good, I should get an output as a true, so that will be mounted. Yeah, so we got output true, it means that we have mounted it. So now I can access all my files all my files which are there inside my raw container inside this tables. But now let us focus on how to create a table, how to create a delta table. So when I'm talking about creating a delta table, there are multiple ways you can create a delta table. So for that, let me show you the documentation of the delta lake. So I'll be sharing you this link, delta.io. So you can just go through this link and if you want a detailed understanding of that. So let me scroll up. Let me go to the docs here. In the documentation, you can see there are a quick start documents here. Now let me create a table. So I am clicking on this create a table. So once I click on create a table, there are multiple ways you can create a table. So this is first way how you can create a table by using a SQL command, like simple DDL commands by using a SQL. You can also create an empty table by using a Python command here. You can see you can just use Python command to create an empty table. We are talking about an empty delta table. So the third way is you can create an empty delta table by using a data frame. We have been doing this. We just say save as table. By default, this will be a delta table. Yeah, so I'm using a three different methods to create a empty delta table. So I'll just make down this as a method one, how to create a simple delta table by using a SQL query. So I'll be using by SQL. So I'll not write any command here. I'll just uh, copy it from the delta.io documents. So you can see very simple, create table if not exist, it should go in the default database and it will create a column name as id, data type, column name, data type, and so on. And at the end we are writing using delta, but now without using the keyword call using delta also, it will create a delta table only. So let me copy this and let me come to my Databricks notebook and let me write it here. So this is a SQL query. So I can just write %SQL and this should create me a delta table. But if I want a new database, you can see in the data view, we have a default database. If you want a new database, we can create a database first before creating a table. So I'll just write SQL command like create. You can write create schema or create database, both will work. Database called delta. So I'll just use delta tables and I'll run this. So when I create this create database delta tables, you got a database that is created here. So you can use or you can give a location for this creating a database also. You can give a location for this database and that location will be your ADLS. So what I'm trying to explain, you can even create a external database also where all your metadata will sit in your ADLS. We will see that later on. Now I want to create this people 10M table in the database called as a delta table. So let me write it here and let me execute this. So I'm using a two-level namespace here, database name dot table name. So you will create a table as a delta table only. Yeah. So you can see here, you got okay here. So you can just go to the data view and you can go in the delta table. You got one table registered, that is people 10M. Now, what is so special about this table? Now you might ask, like, it looks similar to a Parquet table. It's similar to a database table. What is so special about this table? So let me open it. Let me open it and you can see we are getting something called details here. We are getting something called details. You can see the details of that table. You are getting a schema and you are getting the sample data, but we did not insert any records inside that, so your table is empty here. So we will see what happens if you start inserting the records. We will see that in detail, but this is the first method how you can create a table. You can use a keyword called using delta also. It will create a same delta table. Okay, now once you get a table, you can start querying it using a SQL. Just write SQL statement select star from the table name, or you can give the database name dot table name also. You can use in this way and let me execute this. it should return query not return no results because there is no results in that. Okay, so when you are creating a table, if you are not giving any location, so if I are not giving any location, by default this table becomes a managed table. So what I'm trying to explain, what do you mean by managed table? So when it comes to Databricks, there are two types of tables. One is managed table and second is your external table. It is also called sometime as unmanaged table, but we'll call it as an external table only. So to find out that, you need a SQL command, like you just write describe extended and just specify the table name. So the table name is people 10m, and let me run this. So once you run describe extended table name, so it will show you first all the column names with the data types, and if you have something comment on that column name, you can see it here. So just scroll down. Here you get a detailed table information where it shows you that the database is your delta table what we have created. This is your table name and the type is managed table. So what I mean by managed table, so as the name itself indicates, managed means Databricks is managing the metadata of this table. Metadata of this table. So where is the location? Location is in this path. So it is in the users hive warehouse. It is inside a delta tables dot db. So what dot db means, that is we have created a database, so that's why it is showing you dot db and the table name is people 10m. So can I go and see what is there inside this, what is the metadata that is getting stored inside this? Let me come here, let me go to the data view again, click on this create table. It will go to the dbfs here, and inside a dbfs you go to users hive warehouse, and somewhere here you have a delta table.db. so these are all databases what I have created before. So now we have created delta table.db, and here you got a table that is called as a people 10m. Inside that you have got something called as a delta logs. So once I click on delta logs, you got two log files that is having a crc and json files. Now you should start thinking like, what are these files, why the files are getting generated, how they are getting generated? We are going to deep dive into that after few minutes. Okay, so let me come back. Now you might ask me like, okay, this is a managed table, I can understand that this is a managed table, so metadata is getting stored in this location. So can I get all this metadata stored outside the DBFS? That is my real-time use case. Can I store that in my ADLS? Can I store that in a new directory? Yes, that is the use case. So for that you need to create a table that is external table. So while creating an external table, you just need to give a location as a keyword and specify the path. So let me copy this. Now I want to give a location. So if you remember at the beginning we have mounted it, so we got as a true output. What does it mean? So you can write the files back to your ADLS. So for that you need a path. So let me write %fsls to just pull out the path. We already have a path, you can copy from here also, but let me show you, you can do it from here. That is %fsls. It will list down all the files which are then in your file systems. Here I am interested in my mount points, so let me just take dbfs mount. Inside the mount point, my storage account name is SANLY. You can see these are all the mount points what I have mounted it before. You can see NASLY. Let me run this. Inside this we have a container called raw container. Yeah, I can see that raw container, and you execute it, you get one directory called tables there. So I'll be creating a new directory from Databricks only by giving a location as a keyword here. After you write this, you just specify a location as a keyword and you specify the path. Inside this raw container, I will write something called delta tables external. and let me start executing this. Yeah, so I got okay. So what does it mean? A table is created, but what that table is that a external table? So for that, let me use this describe extended delta tables. Let me copy this and paste it here. And now let me run this. And if I, oh, it is still showing me the same name. I'll just change the table name. I'll make this to 20M and I'll execute this. Let me rename this. Yeah, I have renamed it. So at the beginning we have given same name. So and we have written create table if not exist. So the table was existing, so it did not create. Now I guess we have successfully executed it. Now let me run this describe extended people 20M table. Let me see what does it show. Yeah, now you can see, focus on this. So it is showing you the database name, it is showing you the table, and the type is external table. And if you see the location, it is somewhere in the mount point SANLY storage account name, container name, and the directory name. So where exactly this is? So let me go back to my container, have a quick refresh here. In the uh, here you will get a new directory, that is delta tables external. So when I click on this, you will find the delta logs for that, and you can see you got the same crcs and json file. So this is how your external table looks like. So you are bringing all your metadata outside the Databricks. So this called as an external table. And when you are storing all your metadata inside your dbfs, or if you are not giving any location, it will be stored as a dbfs. This is called as a managed table. But you can see both the tables in your data view. You can see both the tables in your data view, that is people 10M, people 20M. But people 10M metadata is getting stored in our dbfs. So this is a managed table, this is an unmanaged table. If you want, you can just write it as a simple query here, just to write show tables. Oh, sorry, let me write show tables here, and let me execute this. So it will show you the default database. You can just write database name, or you can just write one more command like use delta table database. Let me check the database name. It is delta tables. Use delta tables, and you show me the tables in that delta tables. And oh, let me put a comma here. Yeah, you can see the database is delta tables, and there are two tables registered in that, that is people 10M and people 20M. So this is how we can create a simple delta table using a SQL query. Now the important thing is, what is so special about this delta table? You are talking so much about delta, what is so special? So let me come back again, let me click on this. You build a new UI that shows you the details, the schema, and the sample data. We do not have any records in that. It is showing you schema, it is showing you sample data, and it is showing you the details, and it is showing you the history here. So if I just click on history, you will now start seeing the history of that table. You can see you will get a history of that table, creating a versions, creating a timestamp. It will show you which version of this table is. We have not done anything on that, so we are getting 0 version. And we have creating at what time we have created that table. And if you look at this operation, this is a create table operation, and you got all the details about that in this history. If you look at some other tables like Parquet table, you may not see these details and history. I'll show you that in a minute. Now let me come back on the same notebook. I'll just copy this and I'll just paste it here. I'll just skip I'll remove the location. So if I don't specify location, it means I am creating an internal table. Okay, I'm creating an internal table. So, or manage table. I'm creating a manage table. Now, what I'll do, I'll make people 30M. I'll just write a keyword using, I'll not specify delta, but I'll specify Parquet. I'll specify Parquet. Now I know that this will be my manage table. The reason is I have not specified the location, but here I am specifying the file format as Parquet. So now let me run this and see what happens. Yeah, it should execute. Yeah, it should execute, and I should get three tables in my delta table. So yeah, in my delta tables I should get three tables: 10M, 20M, and 30M. So if I open 30M here, and we already opened 20M, and you can see details, history, schema, sample data. But if I come here, you will be surprised to see, you can see only the schema and sample data. Now you might ask, like, where is the details? You don't get these details, you don't get this history, because the reason is this is just a Parquet file or Parquet table. So now, if by looking at these delta tables, by looking at this database, can you differentiate which table is delta, which table is Parquet? No, from this you cannot. But if you are using an Azure Databricks Data Explorer, there you can easily find out by just clicking on this. You may get a symbol that this is a delta table. Now you might ask me, like, why delta again? So I would say that this delta is creating you a delta logs. This is creating us history. Because of this history, you can do time travel by using a versioning. You can do the time travel by using a timestamp. Go back and see what the records do we have, what has happened to that table, what operation we have performed. Everything can be maintained by using this history. Now if I just go back and show you the dbfs, that is managed table, let us see where is the location of this 30M. So for that, let me copy this describe extended delta tables and paste it here. In people 20M, let me write people 30M and let me execute this. So if I execute this, if I just scroll down, and here you can see it is a database is your delta table, the table is your people 30M. If you just scroll down, you can see the last access is unknown, the owner is root, but yeah, you can see a type is managed and the provider is Parquet. Till now we have seen the provider as delta. So what happens if it is Parquet? Let me go back to my dbfs and go to the user hive warehouse, and here I'll go to delta tables.db. Here you should get two tables. People 20M is registered as a external table, so that is in my ADLS. So if I open people 10M, you got a delta logs. But if you look at people 30M, there is nothing here. You will be getting only a Parquet files once you get the data inserted in this. So give me 2-3 minutes, I'll insert some values inside this 10M, inside this 30M, then you will get to know the details, or you will get to know the detail of this delta. So before we insert the records in our table, let us understand what exactly is the managed table. So I'll take few minutes to explain you the high level architecture of this Databricks. So at the top you have metastore, then you have a catalog. In catalog, you have the schemas. It is also called as a databases. And there are few objects of this database. So it can be your tables, it can be your views, or it can be your functions. You do not have a store procedures in Databricks. Then when it comes to table, there are two types of tables in Databricks. One is managed table, one is external table. So what does it mean? So when you are creating a table, when you create a table, so what is at the end point of Databricks is we create a table. And what Databricks recommends, what Azure recommends, both what Azure Databricks recommends, that convert your table to delta. Why? Because there are so many features that delta can do but others cannot do. So we are talking about the delta now. We will see the difference. What is a simple Parquet table, a simple delta table? We will see that. But when you are creating a table, there you can create table by multiple ways. You can create table by SQL. You can create table by Python. You can create table by data frame. In any of the method, when you are creating a table, if you specify a keyword called location and you pass a location, it can be any location, it can be mount point, it can be dbfs, any, just if you write location, it becomes external table. If you are not specifying location, then it becomes managed table. Okay, not specifying location, it becomes managed table. Now you might ask, like, why managed and why external? Why these Databricks are like getting so much confused? Why they have introduced these two things? They would have simply kept it as a table. Why they have brought these two things? Many folks get this doubt. So I'll tell you. So when you are talking about metadata of this delta table, when you're talking about metadata, every transaction, it might be your write transaction, it might be your insert transaction, it might be your creating a table transaction, it might be a delete, it might be a upsert, it might be a any transaction, it is creating a delta logs. Suppose you say that, hey, we have millions of transactions happening now. So will you get millions of delta logs? Yes, you get millions of delta logs. So to manage these delta logs, where do you want to store this? Do you want to store this in your managed? Do you want to store this in your DBFS, or do you want to store that in your ADLS? It is up to you. It is now you need to think other use case. No, I'll keep that in your dbfs. So if you store that in your dbfs, you have to every time come to Databricks to access this, and Databricks is going to charge for your dbfs. It is going to charge for your storage. Now you say that, no, I'll keep all my metadata in the ADLS. Okay, you come and you store it in your ADLS, then you create an external table. Yeah, so this is about the managed table and external table. We have used that now. We have provided a location. It was a managed external table. Without location, it is just a managed table. It is just about the metadata. Your metadata is getting out of the Databricks when you give a location. It is managed table. And one more difference I want to talk. So when you drop, what happens when you drop? So if you say drop table name, if you write this, there is a lot of impact going to happen for the external table and managed table. If you say drop table name, if it is a managed table, obviously if it is a managed table, metadata is in your dbfs and your data dbfs, and your data is also in your database, I mean table. Both gets deleted in your managed table. Both gets deleted. Both, what does it both means? Your data and your metadata both gets dropped if you use drop manage drop table name. If it is external table, if you are saying drop table name, only the data gets deleted. And what about metadata? Hey, metadata is storing outside. Metadata is in your ADLS. How the database can go and delete them? So your metadata stays there. That is the advantage of the external table. So if I drop the table for managed, both data and metadata gets dropped. If I drop the external table, only the data gets dropped, your metadata remains there. So let us do the hands-on this to understand in more deep. So I have three tables now. You can see I have three tables. Out of that three tables, one table, that is people 20M, we have written it as an external table. And for showing this demo, I wanted to show about the metadata also. You can see in the delta table, we have people 10M. Now let me come here. You can see the data here. You can see the metadata here, metadata here. Okay, let me come back and start dropping the table called people 10m. Okay, let me go down. Let me copy this table name and database name. Yeah, I'll copy this and simple. I'll go here and just write SQL drop table table name. Okay, drop table name. Let me execute this. Let me execute this. It says okay. So if I just go to the data view, data explorer, and your data is lost, you cannot get that data now if you go back to the dbfs or your hive data warehouse, if you just have a quick refresh, you click on your delta tables.db, hey, your metadata is also gone, your data is also gone. This is how the manage table works. So if I just go back and show you the describe command which we have run for people 10m, people 10m describe, if you just look at, this is a managed table. That's why this metadata and the data both got cleared or both got dropped. Now, if you remember, in our raw container, we have one folder and that table is your people 20m, 20m. So let me, I have created this as an external table. I can show you here in the describe, this is an external table. So if I just show you this delta tables dot people 20m, and if I drop this one now, if I drop this one, you can see the table which is present in the delta table database. You can see this. When I once I run this, let us see what happens. Once I run this, it is saying okay. So if I just go back, sorry, if I just go to the data view, and you can see your table as dropped. But at the same time, let me go to my raw container and have a quick refresh, and you can see your delta logs still exist, still exist. This is what external table means. So I'm repeating it again. It keeps the Parquet files also here. Yeah. Yeah, so we have deleted the table now, and if you delete an external table, your table or your data gets deleted, but your metadata remains there. Okay, remains there. So now I will insert one record. Now I'll insert one record and let us proceed further. So I want to run this command again to create a, so this will be my managed table. Obviously, I'm not giving any location. So I'll run this. Once I create this, you will be getting a table again with this name. Now I'm going to insert, I'm going to start inserting the record. So give me 1 second. I'll just write SQL query insert into table name. You can use just a table name or you can use a schema name dot table name values. So I'll insert only one record. I'll take ID1. I'll ID1 name. I'll take as Sachin. I'll take surname, middle name as R, and last name as T. Then gender I'll take as M. It is a string, and date of birth maybe I'll take it as a timestamp. So it is 1970. I don't know, maybe 26 of April or so on. Okay, let me write it in this way. Then I'll use an SSN number, maybe 123, and the salary is maybe 5 or 5,000, something like that. Let me start inserting the record inside this. Yeah, I have successfully inserted one record here, one record. So I'll just check how does the table looks like. So I'll just put a SQL query here, select star, select star from your table name. I prefer using the database name dot table name in this way, and let me run this. Let me run this. So you will get one record in this. You can see you get one record in this table. Yeah, you can see you got one record. Everything looks fine here. If I go to the data view, you can just go to the table, that is people 10M. If I open that in a new tab, you will be seeing the details because it is a delta table. This is a delta table. You can see the details. You can see the sample schema, and you can see the sample data also. You can see all the details. Now I'm showing you that this is the details. So what is happening here, there is an history. So if you remember, we got only one version, that is create table. Now we are inserting one record, it is creating one more write operation. So it is showing that okay, one record has been inserted. Now if you are thinking like, hey, what is happening there in the metadata, let us go back. Let us go back and check. So let me have a quick refresh here. This is a managed table, so I'm looking in the dbfs. If it would be an external table, I would see in a container adls. So let me scroll down here in the delta tables. Here you have people 10. Now you will be surprised to see that you got one file. What is that file? Hey, that is a Parquet file. You can see this is just Parquet file. But with that Parquet file, you are getting some delta logs. So if you open it, hey, now you got two more logs, that is CRC and JSON. What are these? Now we are going to deep dive into these files. Don't worry, but just try to understand every insert or every transaction. It will create a Parquet file. Let me show you to you again. So let me come here. Let me copy this to save some time. Let me copy this and insert this 2 3 times. Okay, let me insert this again, put a comma. Oh, let me remove this, put a comma, semicolon, and let me just change the value. It works with the repeated also. Yeah, I have inserted two records now, two records. Let me see what happens. It should give me a statistic that hey, the number of affected rows are 2 and the records inserted are 2 and so on. It is only one transaction, so it is taking as 1 and 1. But if you look at the table here, if you look at the table, you should get three records here. You should get three records. Yeah, you can see 1 2 3. Okay, let me go back. Yeah, you got three records. Now let us see the metadata, what is happening there. So in the people's 10M, you will be getting three part files. What now, you can try to understand what do you mean by three part files. So one part file is holding one record, second part file is holding the second record. I mean, every insert operation is holding, every transaction is creating a new part file. Respective part files, you are creating a delta logs. Again, you got one delta log. So if you go back and just look at the table, let me quickly refresh this. Refresh this. You can see there are three records. If you look at the history, you will getting two more versions here. You will be getting two more versions, and those two versions are write and write. Right, so basically we have three writes and one create table. So every transaction, it is creating a version. So what we can do with these versions, what are those delta logs, we are going to deep dive in the next session. Thank you guys, thank you for watching this video. I hope you understood the clear things on what external table is, what internal table is in delta table. So in the next video, we are going to see deep dive into what are the part files in the delta table and what are the delta logs, what is CRC and JSONs in detail. Thank you for watching this video, guys. Keep learning.